We are going to discuss the periodic table. In particular, we are going to look at alkali metals. Alkali metals are also known as group 1 metals. So how do we locate? Location of these metals. The location is basically the are in this group 1 going down. So these group 1 elements are actually the ones known as alkali metals. And how is the reaction down the group? So down the group, the reaction of these metals is such that the reaction increases down the group. So as you are going down the group, the activity increases. For example, we expect lithium to be less reactive than actually potassium, if we compare this. So potassium will be more reactive than lithium. The reason is that the element, the outermost, the element in this element, potassium, has an electron in the outermost shell, which is further away from the nucleus. And therefore, it is easily, actually, during a reaction, it's easily released or lost. While in lithium, it is closer to the nucleus, where there are protons which are positive. In other words, what we are saying is that if this is the lithium, in the nucleus it has protons which are positively charged, and lithium, the atomic number is 3. So the second shell is going to have 1 electron. The first shell, so electron configuration is 2-1. Electronic configuration is 2-1, and therefore this electron, which is negatively charged, is closer to the nucleus, and therefore it's highly attracted. So during a reaction, it's not easily released. While for potassium, with the atomic number 19, the electronic configuration is 2, 8, 8, 1. So we expect here there are protons. We expect 2 electrons in the first shell, second shell, 8 electrons, third shell, 8 electrons, fourth shell, 1 electron. And so this electron here is away, further away from the nucleus, and therefore we expect that it can easily be knocked off, or it can easily be lost during a reaction. And that's why we said that the reaction increases down the group. So occurrence occurrence of alkali metals. So these elements actually occur as compounds because they are very reactive. So they are joined together with the other elements. So they always occur as compounds because they are very reactive. So now we are going to look at the physical properties. Physical properties of alkaline. Okay, so physical properties of alkali metals. And so the appearance. So these metals are soft and shine. They are soft and shiny metals. And then the softness actually increases down the groove. So we expect that potassium is more softer than from here. This potassium is more softer than lithium because it is increasing as you are going down the group. And so the density is very low, low density. These metals have low density. So how is the trend? The trend of density. It increases down the group. In other words, if we are saying lithium here will have a less density compared to sodium because it's increasing down the group. And then we can look at the melting point and boiling point. The melting point decreases down the group. In other words, what we are saying that lithium here is going to have a higher melting and boiling points. And then as you are going downwards, actually it is decreasing. So the density is decreasing. So lithium has a higher density than sodium. Okay. And then we can look at electrical and thermal conductivity. They are good conductors of heat. Good conductors of heat. These metals are good conductors of heat and electricity. So what about malleability? And that ductility. Well, these can be made into sheets. They can be hammered into sheets, meaning they are made. And they are ductile, meaning they can also be drawn into wires. So this is actually a property that they have. A trend in density, we have already looked at it. And so we can look at the chemical properties. Chemical properties. Of group 1 metals. Basically, we'll look at the way they can react with the other elements. So we'll start with the reaction, how these can react with the oxygen. So alkaline metals actually, when they react with oxygen, they form oxides. Okay, they form oxides. For example, lithium reacting with oxygen, you produce lithium oxide. You produce lithium oxide. So this is an oxide. Number 2, we are going to look at reaction with water. When they react, actually they form hydroxides. They form a hydroxide and the hydrogen gas. For example, lithium will react with water to form lithium hydroxide plus hydrogen gas. This is a gas. This is a hydroxide, which is alkaline solution. Then we can look at the reaction with the halogens. They form actually salt when they react with the group 7. Halogens are group 7 elements. So when they react with they form actually salt. For example, sodium in group 1 will react with the chlorine to form sodium chloride. This is a salt. And then we talked about the formation of hydroxide. So this hydroxide here is the reason why they are known as alkaline metals. Alkaline metals because they form an alkaline solution. They are known as alkali metals because they form an alkaline, so that's why they are known as actually alkali metals because they form an alkaline solution when they react with the actual water. Now we'll look at reaction with an acid. So when they react with an acid, they can form actually, they form salt as well as hydrogen. For example, lithium reacting with the hydrochloric acid, you're going to form lithium chloride, which is a salt plus hydrogen gas. Okay, and so we can balance and put a 2 there and the 2 there, as well as a 2 there. So what about the flame? When they burn, what flame do they produce? They are characteristic flames. For example, sodium, the color of the flame, the color is actually yellow. While potassium, it is actually lilac or purple. And the lithium, which is actually crimson. Crimson red. So these are characteristic colors that you can use to identify these alkali metals. However, if you want to predict other properties of these alkali metals, which we have not discussed. You can just look at the trend of their reaction, as well as the color, as well as the other physical properties, for example, density, so you can easily predict the other elements based on the physical properties and the chemical properties. Thank you.